A good question from the chapter of gravitation. So what we have been asked to find is that we have to find the speed of this rod before, uh, or not. I mean, this rod. Both of these bodies have been released, and we have to find the speed with which they collide. Okay. So this is a rod of length 2r. This has a mass m. It has a mass m. This is a sphere. Okay. Is it a sphere? Yeah, it's a uniform sphere of mass m and radius r. Okay, and the smallest distance between the sphere and this rod is equal to 2r. Okay, so since we have been asked to find the velocity of the body before they collide, uh, you know, let's just think about this term velocity. We usually associate velocity with kinetic energy, right? So what we will try to do here is we will try to use the law of conservation of mechanical energy. All right. In that way, we will get components of kinetic energy in there as well. And yeah, in that way, we will be able to calculate what the velocity can be. Okay. So first things first, let me just draw the this system for you. This is a sphere, and this is the rod. The smallest distance is 2r over here, and the length of this rod is 2r. Okay, and yeah, so in the equation of law of conservation of mechanical energy, there is a component of kinetic energy as well as the potential energy. So let us just find the initial potential energy between these two bodies. Okay, when they are at a distance of 2r. So yeah, uh, it will be easier to make smaller pieces of this rod, right? Because it's a straight line body, it's a linear body. So what we will do is we will consider, say, this small mass over here of mass dm, which is at a distance of x from the center of the sphere. Okay, over here, and we will now calculate the potential of the small mass with respect to this sphere, and then we will integrate the entire thing. Okay, in that way we will get the potential energy of these two bodies as a whole. So du is equal to minus g m dm divided by x, right? Now uh, we have to bring this dm in terms of x, right? So let's do one thing. We know this equation, right? Lambda dx is equal to dm, where lambda is the linear mass density. Okay, so let me just put the value over here: minus gm lambda dx by x. Okay, so yeah, we are now going to integrate this. So du we can integrate from 0 to u, while x we will be integrating from 3r to 5r. Why? Because from the center of the sphere, this distance is equal to 3r, and this distance is equal to 5r. Okay, so we will now put all the values over here: gm lambda natural log of x from 3r to 5r. This is equal to u, and when we put the value of lambda over here, which will basically be mass by length, the value of u will be minus g m square by 2r natural log of 5 by 3. This is the initial potential energy. Okay, all right. Now we have been asked to find. Now we will find the potential energy at the time when this rod is in contact. It has collided with this sphere. Okay, this is the initial u. So in the final u, nothing will be different except for these limits. Okay, these limits will be 3r and the lower limit will be r. Why? Because at that point of time, uh, at that point of time, the distance from here will be r, from the one end of the rod will be r, and till the other end it will be 3r. Okay. Anyways, so the final potential energy UF will be equal to minus g m square by 2r natural log of 3. Okay. Now we will apply law of conservation of mechanical energy. Okay. So Ki plus Pi is equal to Kf plus Pf. Okay, K and P means potential energy, kinetic and potential energies. Okay, so initially the kinetic energy was 0. Why? Because we have released that rod from rest. So yeah, 0 plus this will be, the potential energy will be minus g m square by 2r natural log of 5 by 3, which is equal to, you know, we have to find the kinetic energy of both the bodies, right? So it will be half mv square plus half mv square. Since the masses are the same, so yeah, the kinetic energy will also be same. And the final potential energy over here will be minus gm square by 2r into natural log of 3. So mv square will be equal to g m square by 2r natural log of 3 into 3 divided by 5. Okay, and yeah, so we have the value of velocity of the body, which is gm by 2r natural log of 9 by 5. Now, had you been a smart person, or not smart person, uh, I mean, this is what we call as being very highly conscious in the exam hall. By just by looking at these values, you would have guessed that the answer will be 9 by 5. Oh, okay. Okay, there are two options with 9 by 5. So yeah, you have to be careful. The question makers are also very smart. Okay, and yeah, the answer for you is over here. Okay, this is the correct answer. Okay, so this is how you solve these questions. Don't panic when you see these continuous bodies. Be calm, do your integration properly. Okay, don't mess up in the integration, and yeah, things should be all right. Okay, thank you.